Let's rock. Check this out. Same thing. Common base needs a base, right? So what number, base 6, will give us 1? 6 to the power of 1, of course. Guess what? Just a 6. That's easy enough to do. All right, so let's rewrite this thing right now. Notice that this is plus. Tells you right off the bat, you're going to multiply. Yep, log base 6, x plus 3 gets multiplied by x plus 4 equals to log base 6 of 6. And check it out now. Yep, gone. Look how easy that is. Using a bit of our FOIL magic, of course, we know that this is going to be x squared plus, bada-boom, 4x and 3x, 7x. There's 12 equals to 6. Bring the 6 over, you got x squared plus 7x. Bring the 6 over, you find out that that actually works out to be plus 6 over here equals to 0. So 12 minus 6, of course. Now, PSA this, you've got x plus 6, x plus 1 equals to 0. So x equals to minus 6, and x equals to minus 1. And I know what you're thinking. You're thinking, well, in the last question there, sir, it couldn't be negative. Yeah, but think about what the argument is here. The argument is x plus 3, where all the other previous arguments were just x's. So you got to try them. Put a minus 6 in here. Minus 6 plus 3, yup, in fact, that does not work because minus 6 plus 3 is minus 3, and you can't log a minus 3. But, take the minus 1, put it in here. Look at that. Minus 1 plus 3 gives you a positive number. Check out here, too. You got to try all the logs. Minus 1 plus 4 is a positive number. So your answer, in fact, is x equals to minus 1. Pretty sweet, hey? Okay, now let's do the next question. Whenever I see a question that says answer to 2 decimal places, that scares me. The reason why it scares me is I think it's going to end up using the quadratic formula in here. That's going to be kind of crazy. Watch this. First things first, log base 3, we need a log here. So let's go. Here we go. Log base 3 of some number has to give us 3. Guess what? That's going to be the log base 3 of 27. So that's important to put in there. There's a power right there. So I'm going to start writing these out. Log base 3 of x to the power 2 minus log base 3 of x plus 3 equals, minus, minus log of 27. Okay, log base 3, don't forget. That all equals to 0. How absolutely pretty. Now, what I want to do here, though, is I'd like to leave this guy over on this side because I want x's together. I want numbers on the other side. So let's do that right away. First things first, though, it's subtraction. So you know that we can divide these things. So we got log base 3 of x squared over x plus 3. And we're bringing this guy over. And look what happens. We get rid of that negative sign, giving you log base 3 of 27. Oh, how pretty. Check this out. Dun, 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 dun. The log base 3's can cancel. Oh, that just makes things so much nicer, doesn't it? Okay, so here we go. We're left with x squared over x plus 3 equals to 27 over 1. Our favorite little thing to do is cross multiply. Boom, we got x squared equals to 27 times x plus 27 times 3, which is 81, right? Bring it all over to one side, okay? Because guess what we're going to do now? You betcha. PSA it. The problem is, PSA is not going to work. Think about it. Why do you think back in this question up here, I said answer to 2 decimal places, and it kind of scared me? guess what we have to use? Everybody's favorite, the quadratic formula. Dun, dun, dun. Minus b plus or minus the square root of b squared minus 4ac over 2a. It is going to be on your formula sheet, so don't worry about having to memorize it. Minus b minus a minus 27 plus or minus the square root of b squared. That's minus 27 squared. Okay, minus 4 times 1 times a minus 81. That's all going to be over 2 times 1. This works out to be some really interesting looking numbers. This is 27 plus or minus the square root, and I've done this for you to save some time, 1053 over 2. Now, you've got two situations here where you can add and where you can subtract. So if you add this, you end up getting a number of 29.72. Okay? Go work it out on your calculator. You'll see. The other number here is minus 2.7. And again, remember, you have to verify. So taking those numbers and going back up here, look what happens. Where's our question? Way the heck back up here. Again, that's just a simple log x, right? So if you put in a negative number, it doesn't work. Okay, so this guy is toasted. The other one is 29.72. Let's go back and take a look. Can you put in 29.72 here? Yup, and take a log of it, no problem. Can you put a 29.7 into this? X plus 3, that's going to work, no problem. So your answer, in fact, is 29.72 to 2 decimal places. Wow. We have one question left. Holy smokes. Okay, after that one, I almost need a break. All right, let's go to the next question. Little bit of podcast magic, and we're back on the last question we have to do for this podcast. This is E. Now, if you look at this one, ew, this looks really, really, really tough because you got a log of a log and it's just a mess, isn't it? Not really. If you remember your logs to exponent rule, think about this. This is just 2 to the power of 1. 2 to the power of 1 equals to, guess what? Yup, the log-based x of 3x plus 4. Interesting that we have now an x here, right, as a base. Yeah, so what? Ta-da! This is just going to be x to the power of 2 equals to 3x plus 4. Well, that wasn't that tough, was it? No, it wasn't. Bringing everything over to one side, that's 3x squared minus 3x minus 4. That all equals to 0. And check this out. Yes, PSA time. This is going to be x minus 4 and x plus 1. That equals to 0. So your x can equal to 4 or minus 1. Right? Okay, so let's check to see which one will work. And again, if you put in a minus 1, let's see. All right? Put the minus 1 in here. 3 times minus 1 is minus 3. Minus 3 plus 4, hey, that's a positive number. But don't forget, the minus 1 also has to be as a base. And you know and I know, you can't have minuses as bases in logs. Ah, rats. So you only have one answer, and that'll be 4.